and welcome back to another Robotics tutorial. Today we're going to be building a basic pick and place demo. Through a combination of the Dobot drag function, jog function, block lead programming and point editing, and SCStudio's gripper plugin, you should be able to build a routine that looks something like this. But before we start automating, we first need to install our gripper end effector. For this demonstration, we'll be using the DH-Robotics AG-145 adaptive parallel gripper. However, pick and place can be performed with any kind of gripper. First, mount your adapter plate, making sure the dowel holes are aligned. Screw in the 4 countersunk screws. Place the small dowels on either side of the adapter plate. Mount the gripper, keeping in mind the dowel's alignment. Install the 4 socket screws on both sides of the gripper. Plug in the control cables. Pay attention to the alignment of both connectors. Once complete, turn on your control panel and robot. If you see a blinking red light, you did it right. Finally, in SCStudio, install the DH plugin. Press the init button on the control panel. Your gripper will run through an initial calibration step and the light will be a solid color. So now that you have your robot installed and your gripper set up, we're going to move on to building a basic pick and place application. So to start, we're basically going to get it close and then refine it very slowly until it is like perfectly aligned with the fixture. So put it in drag mode. Bring it down to here-ish. Turn it out of drag mode. Come into this point menu, add a point. Have it go to point 1. We will save that. And instead of having this like rotation of the end effector, so instead of 176, maybe we'll set it to 180. We will set this to 0 and this to negative 180. And then when we go to that, instead of being off, it will square itself up. So we'll save it and run. Okay, and you saw it adjust, and now it's squared. And here is the jog panel, which we introduced in a previous video. We're currently in the user frame instead of in joint. And in user, we can move up and down, we can move Y, and we can move X. We also have the ability to move in Z, or rotate about Z, rotate about Y, and rotate about X. So we just squared up with X and Y, so we don't want to change that, but we will use Z. Okay, so we can move up a little bit so we're clear. Close the gripper, and we can really dial in on the block here. So we need to move it forward, and then we need to move it this way. Okay. We can get really fine adjustment if you click on this menu and drop down. So instead of jog, we're going to set it at 0.5, which is ½ millimeter. We want to move it a little bit away and a little bit this way. So it's actually kind of a lot this way. Okay, that looks pretty good. We will open our gripper and move down until we are able to pick it up. So let's say about there. Let's see what that looks like. Ooh, just barely missed it. Move down a little bit more. Try again. Okay, that looks really good. And we will save that point. We'll just overwrite our first one. To overwrite a point, you can click cover. And that just overwrites all the values. So we will call this, right down. So right because it's on the right side of the table relative to the robot, and down because it is down inside the fixture. Or at least the block is inside the fixture. Okay. we'll save that. And we can move it up out of the fixture, which will give us a sort of clearance, before we actually move into there. So we'll move the Z up. This also lets us know that we did clear that perfectly. And we'll save this point as well. So we'll call this right up because it is out of the fixture. We'll save that. Okay. And so kind of my thought process behind this is it's going to start at a vertical state. All of the joints are perfectly aligned. They're all at 0. It's going to come down here into its first point. Not first point on there, but the first point chronologically, I guess. So it can clear all obstacles, and it'll move down linearly. So the first one is going to move down joint-wise, I guess, and that is all of the joints will start and stop at the same time. They will all have the same kind of acceleration as it moves through. So that kind of looks like this. So if I want to move my hand from here to here, I can go like this. So that's really exaggerated, but that would be what joint looks like. If I want to move in L or linearly, we go here and we just go straight there. So that's a straight line. So it's to start at home, first point, down, pick up the block or grab the block, close the gripper, move across the table to its third point, which will be above this hole in the fixture, move down into the fixture, drop the block by opening the gripper, move back out for clearance, and then come back to home. So we'll try to design it around that thought process. And we want to move the block from that side to that side, so we'll do it this way. A little slow, we can speed that up. Oh. We'll get it closer to the fixture so I can see what I'm doing. Okay, and it looks like it's pretty well aligned with the hole that way. We're going to rotate about the Z-axis until it looks to be aligned that way. So when we installed this, we kind of just threw this plastic on, clamped it down. Obviously not perfectly aligned with the robot, not perfectly aligned with the table, so there is a little slop. So we can use the rotate about Z buttons to compensate for that. Okay, that looks good there. Move down a little bit more. Okay. Okay, so I need to move it this way, and I need to move it this way. So we can reduce the speed, or go from jog to 0.5, and move it this way a little bit. Okay, I can see that. And we can move it this way. Okay, let me just check that one last time. Okay, I might need to move it a little bit more. Let's go down and see if this fits. And that looks really good. Okay, so now the block is in the fixture. Let's go back to Blockly, save this as a point. We'll call this left down. And save that. And we will go up a little bit. Let's take this out of jog mode, or put this into jog mode. Move it there, so that looks good. And add that as left up. Oop, spelled that wrong. So this alias really isn't used by the machine at all. It is more supposed to be like human readable, just a label for yourself. Let's save that all. Okay, and now we can build our program. So like I said, our goal is to have it go from home, above the block, grab it, go back up, bring it across the table, go down into the fixture, open the gripper, move up just a little bit, and then come back to home. All right, so to go to home, going to do joint move to 0. And you'll see me adding these sleep blocks. The reason I do this is because between each instruction that I send, I want to make sure that all movement stops and resets, just before it starts executing the next instruction. We are going to move in J to point 2, which, if you remember, was right up, so that is above the block. We are going to then wait another second and move down linearly to point 1, which is down in the fixture. Go down to DH, and we are going to open the gripper to grab, or no, I'm sorry, we're going to actually close the gripper to grab the block. Wait another second. Move relative to the point where it is. So this rel move J means that it is going to move relative to whatever point you select. We're just going to do the current point, and we're going to have it go 50 in Z above where it is. Wait another second, then we're going to move linearly across the table to, I believe it was 0.4, yes, so, okay. Move again to 0.3, we're going to set L. And so for this one, when we are putting it into the fixture, we're going to want to slow down a little bit. So we're going to go to this Align Speed Ratio button. And before we go in, we're going to have it go to 10. So 10 is 10% of its maximum speed ratio. It's going to move down, close the gripper, and then we can speed it back up after this. So we go to move, line speed ratio, whatever our current global speed is, let's say 80. Okay. Wait again. After we close it, this happens almost instantly. So we move up again relative to where we are. Linearly, of course. Okay, and now we're sitting above it, so we can just move home. So we do, again, joint move J, and we take this joint data filled with zeros. Okay. So just to recap, before we actually execute the movement, we are going to move to home, which is the completely vertical position. We're going to move joint-wise to 0.2, which is above the block here. We're going to move down linearly to 0.1, where it is about to grasp it. We are going to close the gripper to hold on to it, move it up 50 relative to its current point, slide across the table linearly to 0.4, which is above the left side of the fixture. We're going to slow down before we move down into the fixture, where we will close our gripper. We're going to speed back up to 80 as we pick it up 50 above where we currently are, and then move back home. So we'll save and run it. And there you go. That should show just how easy it is to work with the Dobot and the Dobot SCStudio. We built a pick-and-place application in maybe 10 minutes. While this is a very simple one with very high tolerances, very little accuracy was required, but even more fine movements, more fine accuracy, those can also be done.
Thanks for watching. We hope you enjoyed it and maybe learned something new today. We'll have links in the description below to any of the kits or hardware that you saw in the video. Remember, anytime any of that's purchased, it helps us as a company keep producing free content. Please feel free to comment in the comments below on things that you're interested in or questions you might have, or any ideas about future videos that you'd want to see us get into. We're always interested in seeing how we can help the community keep innovating.